Hey everyone, today we're going to do a video on this tower. I can't remember exactly what it's called, but it'll be in the link in the description and in the title of this video. But today we're going to make this facade form. This will be the final part of the series of how to learn Grasshopper in terms of just a precedent and kind of understanding how each kind of command works. And I thought this would be kind of a fitting way of finishing where we start off. So in the very first tutorial, we learned a twist with a series, twist with series and range, and in this one, it's very similar to that. So we're going to make this base right here. We're going to make, can we zoom in here? Let me see. Zoom. Oh, perfect. We're going to make this base, not these two things, but just the base of this, kind of the formwork. Then we're going to make this twist motion right here. And we'll make this twist motion and just the massing of this cylinder and a little bit of the paneling. So yeah, I will put the photo in the link in the description along with the Google Drive folder with the script when I'm done. So let's get started. I'm just going to close this out. And now I'm going to start the Grasshopper script. So I'm going to keep it in perspective mode. Most of the stuff we've been doing has been in top view, so let's do it in perspective. So actually, I'm going to make sure my units are in feet this time. So I'm going to go to options in my Rhino. Let it load. Sorry. It's running a little slow right now because I have a lot of stuff running. So I apologize if you hear the fan noise in the background. It's actually an ambient noise in a sense, so I think it should be fine. It's actually millimeters, so let's change this to feet. And that should be good. And yes. And that's it. So now we have it all in feet. So awesome. So let's start with a simple polygon. So we remember what we looked at. It's basically a cylinder and then the wrapping of this kind of twist motion, these kind of weird twisting motions. So let's start with a polygon and a cylinder. So let's do that. The base, the radius, and then the length is what we have right now. Sorry about that. Let me just have some stuff on my desk. I'm not at my normal recording desk. So we have the cylinder. So let's start with something like 12 feet in radius. It's going to be large. Yeah, it's pretty big. That's what we want. And we're also going to do a larger radius in the polygon. Do addition. So if we think about it, that twist is on the exterior of this cylinder, so we always want it a little bit larger than this cylinder. So I'm going to do an addition and do a 12 plus 3. Let's try that for right now. 12 plus 3 as the radius of this polygon. So if we remember, that twist only had 4 twists to it. So if we think about it, that's like a square. There's only 4 sides. So let's just try that out. I'm not too sure how this is going to work out, so let's just do 4. 4. Okay, we have 4. That's perfect. All right. So right now we have that 4. What I'm planning to do right now is do the twist like we did in series in the very second part of the tutorial, and just use these corner pieces as a way of that to create that twist or to loft it. If you don't understand that now, we'll get to that soon. So I'm going to make the length about probably 100 feet, because to make it somewhat to scale and accurate to how it looks. It keeps doing that. 100 feet. That looks pretty large. Alright, cool. Nice. And I'm also going to cap it. Cap holes. Nice. Alright, so that's a complete cylinder. That's just the base done. So that was easy. So we can turn the cylinder off and keep just the capped holes one. The capped hole resultant geometry we have right here. So to get started now, we have the polygon. And what we're going to do is we're going to do kind of the same thing that we've been doing for the last parts. We're going to do a move. Or for lesson 2. So this is a lot of lesson 2. Do a move. We're going to move in the Z direction. I'm not plugging this one in yet. And then we're going to do a series. Plug that in here. And then we're going to do step is going to be probably 3. And then our count will be somewhat high. So let's make it 12 right now. Actually, let's make it 0. So it'll range from 0 to 100, as you can see. As you can see, it just does from 100. So we can change that from 0 to 100. And let's plug in the geometry. It's gonna freak out because there's nothing happening, right? See this orange stuff? These right now is at 0, so we have 1. So now we have a lot of it. So we can technically make the division of this. We can technically make what's it called? The division of this, the exact height of this cylinder, and that's exactly what we're doing. So we know this is 100 feet. We can actually say the steps. It's a division thing because we just say we do a division. It's 100 feet divided by 3 should be the resulting step count. Oh no, sorry, it's the count. So if this is every 3 feet, and this is 100 feet in length, we can determine that by saying, let me think about this. This is a little tricky because I want to automate everything, and I kind of want this to be even height with this. I forgot how I've done this already. I just can't remember how I did it. This is every 3 feet. 100 divided by 3. About 37. Let's say I want the step to be constant, and I want the length to be, it's 100. So that means it just needs to be 100 divided by 37, right, to get the spacing. Yeah, so we do the division. Right? Well, we're missing 1. Yeah, so now it's working somewhat, but we're missing that 1 because I think we're thinking a tree counting principle. Forgot about, oh wait, hold on. 22 addition. It'll always be +1. Yeah, there we go. So, so now we have it to where it will always be the same height as this rectangle, no matter how many we add. Awesome, cool, we did it. That was just a simple math kind of configuration. So we have move, and we're going to do another move. We're going to do another one, the z-axis. And we're going to do, instead of a series, we're going to do a range. Range, plug in, geometry. The steps is the exact steps of this. So there is 26 of them. There should be always 25. So in turn, steps. We do it. Construct domain. And we're not going to do a move, actually. Sorry about that, guys. We're going to do a rotate because we want to now, if we learned in lesson 2, we need to rotate this. Sorry about that. We need to start to rotate this square now to create that twist motion. So let's do that. This needs to be in radians. Sweet. And plug the geometry in. Nothing's happening. And then we plug in the domain. Right now the domain is just 0 to 1. So boom. So it's still the same, right? Nothing's happened. Technically, if we look in top view, we can see there is a slight rotation of 1 degree, which is not even noticeable. So let's do that real quick. We're going to do a 0 to 45 degree turn. Let's plug in 0 for the sake of clarity. And now it's going to do 45 degree turn. Now it's doing 100 degrees. And I'm actually going to set this slider to a range of 360 because that's the maximum amount of degrees you can get. And now we can start to actually get a giant twist here. Cool, nice. And then we can start to actually now add more if we want to create how much we want to define it. Nice. All right. Now that we have that, we're actually going to take, we only want the corner geometry of this. See this? We only want the corner geometry so we can kind of trace it. So let's do an explode. And now we exploded the geometry into these points now, as you can see. So we're going to do a list item. And the reason why we're doing a list item is because we want to actually capture all of these points. So, do a list item. We're going to copy each one of these points. All of these are already nested into a list of 1 list, 2 list, 3 list, 4 list. You just need to grab them. And if you look, it should be 0 through 3. Am I presuming correctly? Yep. Oh, no, 0 through 4. Huh. Okay, it's copying, if you do 15, 0, wherever 15 is, 15, 0, then 0, 15, no, 0, 15, negative 15, 0, and it's just copying this last one. So it technically is 0 through 3, but for some reason it's copying the last one. So we don't really need that one. I'll do a list item. Actually, before I do that, I'm going to now move this panel up here, Control C, and then Control V 3 times. Oh, one more time, 4 times, sorry, because we want all 4 of those. And we're going to move this, and we're going to move this, and we're going to now straighten those. We'll just plug in all the list items into here. And then we're going to set each one of these numbers to the respected list here. So this would be, we're going to do a number slider for 0, 1, 2, and 3. We don't want to do 4 because it's the exact same thing. So we're going to do 0, 1, 2, 3, 3. Nice. Okay, cool. So 0, 1, 2, 3. So as you can see now, they are now respectively capturing 2, 3, 4. Also, they're capturing each one that we want. So it's capturing, this is 3. Let's go to top view and see. Oh no, we can't see in top view. If we had a 0 rotation, we can. So let's do that actually so we understand the list manipulation that's happening. Top view. So this is 0. Oh, this is 3. 0, 1, 2, 3. And this is 4, but we don't need that copied twice, so it's pointless. So we're going to draw, these should be in a list of some sort. Let's check this out. So this is all grafted right now. It's not going to produce anything if we do like a polyline or a, because we want to draw a line through this entire thing. So let's do that. So since this is grafted, I'm going to flatten. Do I want to flatten it? Can I try doing interpolate without this? Interpolate. So interpolate is basically what I just typed in, is a way to create curves based off of, create an interpolated curve through a series of points, or through a set of points. So basically it's just drawing a curve exactly where that point is. I don't think this will work. Nope, of course it won't work. Because right now there's no data. It's just all grafted. So let's try this. And that gives it the sufficient amount. And we're going to highlight that green. We're going to keep that green. And I'm going to show you that it works. Because right now it's just drawing a giant straight line. And as you see, it's twisting it along with it. Nice. So it's working. So flatten. And then 3 more. Wait, this last one. And just, actually let me just straighten them all out. There we go. Nice. Flatten them. Because right now the lists are grafted, which doesn't help us out, so we're just going to flatten them. Okay, interpolate. So another 3. Sorry I'm going a little fast on this one. I just assume that if you watch the other tutorials, you will understand how to do this part, or understand how to do this. So interpolate, we just plug in the tree, plug in here, and plug in here. Awesome. So now we have all those curves now matched, and we can start to get to the actual cool part, which is creating that rectangle. So we're going to actually check out that cylinder again to make sure we're not interfering, and it seems a little too close to the perimeter of the cylinder. As you can see, it's a little close, so I'm going to bump that spacing up. So let's do that. This looks like some DNA fusion thing right now. So once we have all this data, or this list, we have these interpolate curves. So you're like, what are we going to do with it now? With those curves, we're going to draw a, what's it called? A horizontal frame or perpendicular frame. So we're going to do a perpendicular frame. Which one is it? This one. And then we're going to draw, and turn off right now these. So we just get the curves. We get a perp frame, and then we're going to do a sweep. One. So this is the first time using sweep, so I'll go a little slower on this one. A sweep is basically a way to make any shape piping. So if we look at pipe, this is what pipe is. Pipe is basically, if I plug in, say the same curve, it'll create that pipe along. It's basically, a pipe is basically a sweep with a circle. So why don't we just do a sweep is basically a pipe, but instead of it being cylindrical, it's any shape. So it could be hexagonal, it could be square, it doesn't matter. The point is, it doesn't matter. So what we're going to do is create a rectangle that we want. And we're going to make it on the plane of this one frame, or these frames right here, sorry, these frames. So we're going to put them on the frames. We're going to draw them. We're going to say, I'm thinking, how big do I want these? I'm going to say, probably, if they fit room, I don't know, it's like 10 by 20. It doesn't mean, it just needs to look correct. I know you can mess around with the numbers. Just want to see x. What does it read as xy direction? Right now it reads as xy, so I want it along this way. So in the x direction, it should be the longest, and the y direction should be, Right now it's just creating that rectangle. At that point, is there a center? Is there a rectangle that makes it to a center? There's not. So. What's a radius? This is fillet? Yeah, corner fillet. Let me think. Rail is just that. I'm going to draw or to find a construct point. Actually, I'm going to construct point. The frames should all fit here, x, y, z. So I have those points. That didn't work. So let's figure this out. Alright, so that should be enough to draw it on those. No, it's just the center. It just starts. It's weird because it starts the rectangle there. I want it there. I should draw it on that plane too. That's the weird part. Okay. Maybe it's this one. Okay, so it's actually drawing it to the frame now. Versus this one just drew it. Oh no, it drew it to the frame too as well. I guess you could use either one, but this one is more, I think, curved parameters. I'm not too sure about this one. I know both of them kind of work very similarly. I just don't know why there's so many. Like, how do I say it? It doesn't start from the center, and it's really annoying. Huh. Let me check the rectangle again one more time. Rectangle. Can I move it to that point? Origin. origin. Plain origin. This looks like something I could use. Base. Origin. Create that from next. Okay, anyways. Sorry, I don't want to waste your guys' time too much. Sorry about that. I will just draw for right now, a center box. I got it. Okay, here's the workaround I'm going to do. I'm going to make a box, quote unquote, and I'm going to say the z-axis thickness is 0, so it creates a rectangle in the center, and make it a xy of, I don't know, of 10, 20 I just had. So x, 20, 10. Okay, that's what it looks like now. Alright, and then we can start to lower the numbers in proportion to each other. Well, let's just make it that. And we can lower this. Yeah, alright, that looks somewhat decent. Better than what we had. Awesome. So, I just made it 0 thickness. What does it say right here? Input rail. Yeah, there's no rail. Yeah, gotcha. Right now it's saying data conversion from box to curve. Yeah, it cannot. It has to be a curve. Is there outline? Sorry guys, this is just some troubleshooting that I'm going through right now. I can't remember exactly how I did this. I don't want to look back on my cheat sheet because it's kind of pointless if I teach it like this. So we're just going to stick with the rectangle right now, or I'll stick with a square. Squares. What is this? Square or a polygon. Sorry, I'm getting distracted a lot. So let's just make the segments 4. I don't know why I just can't do the rectangle in the center. I feel like that'd be really the most popular. Oopsie. There we go. And then we're going to should I do rectangle actually? Well, now it's creating it in the center. I don't know what I just did. 10. Oh, it's just creating it in the axes. Right. It doesn't like proportionalize it. It just kind of makes it. Versus like if I have it like this, it will create it in the center. Right now it's saying one locally defined value, -1 to 1. So what I do a construct. As you guys can see, I'm just working through the problem right now. I'm not actually like a master at every single thing I do, so it's actually interesting. I think I never edit out my troubleshooting because I feel like troubleshooting is a very important aspect in Grasshopper modeling. So I'll never edit me struggling like severely out. It looks embarrassing, but if it helped you guys out, that's perfectly fine with me. See, nothing is okay. So that didn't work. Right now it's saying 0 to 1. Alright, let's try that -1 that we had originally. That's old. Nope. Wait, what? That was old? Okay, whatever. Negative. I'll do like 0. And then we'll just move it up from there. 4. Alright, cool. So that's how you do it. You have to keep it proportional between the domain starts. Or, no, because this needs to be, something needs to be negative here. So this right now will be the negative there. I'm learning the rectangle tool because I usually don't use that. You just use a polygon usually. That'll be 1, 0, that'll be 4, 4. And this one will be 10, 10. Negative 10, 10. Well, actually, I only need to use a different one because I want it all automated. So I'm going to keep it like that. Awesome. So I got it like that. Nice, nice, nice. So that's what I wanted. I have something like this. I need it kind of rotated. But, so if I want it rotated, I'm just going to swap them. Boom. Boom. Alright, nice, nice. I got it. Alright. Sorry about that, guys. Again, I do this, I show my troubleshooting, because I think is important. Alright. So I am going to now do the rail, or the sweep one. So I'm going to explain it since I've never went over sweep before. Sweep is basically, like I said before, it is just a pipe. It is just a pipe, but instead of just a cylinder, you can do it with any shape. So sweep is very important, especially sweep one. Sweep one's super easy to use. I thought it was hard to do. So if you want to sweep anything, you're going to start with the curve that you have. So I had this curve, that's why I was trying to create it. You start with the perpendicular frames. You can also use the perp frame. You can also use this one. I'm not too sure the difference between these two. This one seems to have less control, in my opinion, but I may be wrong. And this one is just a rectangle. So I create a rectangle along all those frames. So it basically tells the computer where to sweep it, or like how to kind of snake along that curve like a pipe does. And then I just throw. And it asks for the rail, with the rail curve, which is just the curve that you're going to use as kind of that weaving manipulation you have. So which is this one. And then now it's asking for this section, which is what shape do you want, weaved on there. And we're going to use the rectangle. And that's what we got. Awesome. So we got that kind of articulation going here. And I actually want, doesn't look quite right. I want it to look a little different. It needs to not, it looks a little close to the thing. So I'm going to actually push the twist even further. So let's do 12 here. And we're going to kind of push it back. There we go. Alright. There it is. We have our twist now. The twist isn't that super severe, so I'm going to change the twist as well. Something like this. Maybe it is. Let me try. Yeah, let me try what it looks like here, because I saw it. This should be the right view. The tower would be taller in order to create that type of twist. So let's just make it taller. Instead of 100, make it 200. And it's going to freak out. Yep, yep. And then we got that 200 foot tall tower. Awesome. So we got that twist motion kind of going on here. That's just the principle of the twist, though. So we have that down. It doesn't need to be exact what I want it, or exactly how it needs to be, but it's a really good replica, nonetheless. So I'm going to actually tone down. I want to make it a little closer. There we go. That's good. So maybe 10 was the perfect amount. I thought maybe I want it lower, or I mean higher. So let's go back to our end of the script here, sweep 1, and we just need to do that for the rest of them. So I am just going to do that for the rest of them. And in fact, since it requires so much typing, I'm just going to copy and paste them. So you can just copy and paste this whole thing right here. Actually, I'm going to type in the second one before I do that, just to teach you guys how to do it. Because I feel like when I type, I always learn more. And that's just how I am. So I can always use this as a cheat sheet since I already did it. So we can do a perp frame, spin the curve, and makes the frames. And then we're going to do a rectangle. And since we want what I know is that since we want all the dimensions the exact same, I'm going to actually use the same construct domains for each one. So this will be the X, and this will be the Y. And we're going to draw a rectangle here. And then we're going to do a sweep 1. That's a mesh sweep. Sweep 1. And this tutorial I'll also show you a little bit of lunchbox. Oh, wrong one. Rails should go into the curve, the base curve, and the rectangle should go into sections. And then we're good. Awesome. So it's basically like these consistent 3, while these 3 are just a little group. Nice group. Nice little group. And then we have drag down here. And now that we know that, I'm just going to copy and paste. No, I'm not. I'm going to do a prep frame. I'm going to type the rest of it out, actually. It just because I don't know it that well, so I want to learn too as well. Again, as a modeler, you should always be willing to learn constantly. You're not always going to be perfect, and that's just how modeling is in general. You're not going to be perfect, and sometimes doing it the longer way will help you out in the long run learning, and you will it'll just be beneficial. CV. There's just certain things that I copy and paste, like rectangle. I don't know how to use a rectangle, but I don't know how to do the XYs. So I'm going to plug them into here. There's certain things I do copy and paste just out of habit, because when I model, you know, that's not on video, I just kind of copy and paste sometimes. And a lot of times I do if it's like very simple stuff. But if you're still trying to learn Grasshopper, I would highly recommend just type everything, even if it's like copy paste stuff. That's how I did it, and then I kind of gotten this decent, so yay. We got to put the plane into here. Forgot about that. Boom. Boom. And then this one. And then finally, we're going to put the railing onto this last curve and section this curve. Alright, sweet. So we have everything kind of not organized. So we're going to align everything, and align everything. Nice. It's somewhat organized now. Yeah, at least it's all the sweeps are in one area. And now we can do cap holes. And we're going to cap them all the same. We're going to put them all in one branch. That's all we're going to do with them. So we have that twist now. It's a little big, honestly. It's kind of covering a lot of it. And in fact, I don't think the twist is that severe now that all 4 is on there. It's going to be more like that. It's more like this. It's pretty big, so let's not make it that big. Let's make it around, I don't know. Let's not make it that big. But we have our parameters here we can control now, so we can look at it and just kind of judge based off of I. 10, it's pretty big. What's the 4 give us? Just thins it out. Alright, that seems pretty good. It's not going to be an exact replica, but you'll definitely have, like, if you want to make it exact, you can. And that's important. So awesome. So we have now that cylinder and that twist. All we're missing is now that base that we said we were going to make. So let's start doing that. We're just going to start a new script here at the very bottom. And we're going to do a circle. Yep, circle. And we're going to look at the radius we used, which is, what did we use? 12. So we used a 12 radius. So we're going to do bigger than that, definitely bigger. So addition. And then we're going to say it's going to be 15 radius bigger, or 15 inches bigger, 15 feet bigger, sorry. So it's going to always be 15 feet bigger than the radius. Yep, correct, amendo. Awesome. So now we have the radius, and as you can see, it's bigger than that, and it's in the center. And then we're going to do another circle as well with the same parameters, except it's only going to be, let's say, 5 bigger. So we're going to go back to that, plug in, oopsie, this 12, and then we're going to plug in the results. And now we have this circle, as you can see, and this circle. So what we're going to do now is just move the 2 circles. I'm going to align, I kind of organize a little bit as I go. We're going to now move this geometry up in the z-axis. I turn this off first, move it in the z-axis, and actually start to get some depth on this. So let's move it 12 so far. Let's make it a little higher. Yeah, like this. That's perfect. 24 feet. And then now all we need to do is lock those two to create that base. So 1, 2, and then cap. Cap holes. We got it. Boom. Done. So we cap the holes, and we have that base now. So now we have the base, the cylinder, and the twist. What we're missing is the paneling of that cylinder. So we're going to find that cylinder that we used. So it's this one. And we're going to panelize it now. Now, we can technically panelize it by using the primitive kind of technology we have. Not technology, but the surface manipulation we can do. We can technically start to divide up the surface and do that. We can, but I don't see why we do that. We can actually just start to create individual panels for them and actually start to manipulate them if we want to. So let's find Lunchbox real quick. It's in one of these. So we are actually going to use Lunchbox for this script. If you do not have Lunchbox, you can download it. Link will always be in the description. Lunchbox is one of, if not the best, plugins for Grasshopper. There's all the other ones, as you can see. There's Diva, Salamander. This Salamander one is relatively new, so I'm gonna learn it myself. Over break right now, I am going to learn this program along with Diva, and when I do know these two programs, I will definitely get back to you guys with a tutorial on them. Ladybug, I may learn. I just have it just in case. I also have this one. I don't know what it even does. I have Millipede. I don't even know what this does. Millipede is kind of a weird program. Apparently, if I drag it in here, it's outdated, so I get this weird kind of plugin, kind of quad meshes stuff. I have Kangaroo Physics, Honeybee, Lunchbox, Kuka, which is the robot arm for our school, extra stuff, and LMTs. I don't know what this is. I don't even know what this is. So yeah, that's just a tutorial or kind of a tour of my what is it, dashboard? I don't know what it's called. Tabs? Yeah, I have a lot of them. So let's start with the Lunchbox. We go into Lunchbox and we see all this stuff. We're only going to focus right now on the panels. I will go over this in a future video, and I will definitely go over more onto this. But for right now, we're going to use where is the quad panels? We're going to use quad panels. So we just have the surface and the UV division. So if we go back to kind of the surface that we want these cap holes. This is right now a BREP, or a BREP, sorry. Not BREP. I call it a BREP, but it's really called BREP. But anyways, we're going to not use this cap holes. This was just to understand that it was a solid, and we're going to use this cylinder because it Grasshopper reads cylinder as a surface. So we're going to put that in here. Right now, when working here, it would say error, as you can see, because technically rep is not surface, or B-rep, whatever floats your boat. So right now, the UV division is 10 to 10, so 10, 10. So it's basically 10 by 10. So 10 in the X directions and 10 in the Y direction. So it should be a perfect 100. So let's make it 15 by 15 because that looks pretty good. Awesome. So we're going to highlight this and start to actually play around with the paneling. So let's just stick with that. This is 37. That's a lot. And then we're going to join them all. So brep join or brep join, whatever floats your boat. And it's loading, and then we're going to do a little cap flip. And this is going to lag a little bit. Not too much. It shouldn't lag too much. Okay, cool. So now we have a capped brep surface. And now we can actually start to, we can also, if you want me, should I boolean this up? And, yeah, I'm going to boolean it. Actually, I'm just going to leave it like this right now. You guys can choose to boolean it. This is just a tutorial on mainly just the twist in action of this, which I think is important. So, a lot of stuff to bake. We have to bake this, this, and this. So I'm going to start with this since we're already here. Bake, group yes please, and it's going to bake it. Awesome, done. As you can see, it's already done here. And I'm actually going to click shaded so we can start to see it. Nice. Okay. Next one is this one, the panelization we just did. Alright, cool, nice. And then now finally the twisting. Bake, yes please. And then now we're done. Awesome. And I'm going to close this out. And now we have this twisting motion. And now we have that tower kind of massing done. So this is my tower now. Let me go and go in the rendered view. So now we have the rendered view. That actually looks really cool even without being a tower. Awesome. That looks really nice. Anyways, so yeah guys, let me open up Grasshopper just to. So what you would do is you would save it to as well. I'm going to save it after this video ends. So yeah guys, that's pretty much it for this tutorial. Thank you guys for watching. Hope you guys have a great day, and I really hope you understand this video. I try to make it somewhat intuitive. So yeah guys, thank you guys for watching. Bye.